chairs around here. It's going to be a little bit tight, so there might be some more space to sit on the stage. No, I'm going to stand. You go ahead, yeah. And we're going to expand out into the rest of the gallery after this introduction, so your spatial needs will be met better. But yeah, do come in if you're at the back. There's a couple of chairs here, or you can come and sit up on the stage. You can come up this way. Yeah, go for it. Maybe some people come around. Yeah, perfect. Yeah, perfect. Yeah, for sure. Yeah, I think it's okay for now. You guys might need to refresh your neck. Cool, and if you want to start recording on the thing, that's fine. Alright, cool. So yeah, sorry we're starting a little bit late, and thank you everybody for coming. And I deliberately oversubscribed from the 12 people capacity because I thought a ton of people wouldn't turn up, but I'm pleasantly and generally surprised that everyone turned up and more, so that's good, that's good. The way it's going to go for the next, I don't know, two or 3 hours is that I'll start off with a bit of an introduction, just some kind of very basic presentation about artificial intelligence experience, and then I'll kind of describe what it is I want you guys to do. In short, we're going to be responding to a speculative future scenario. I'm going to explain in more detail presently what that means, but you're going to be working in groups. I'll need to recount, but I think groups of 3, and then you'll respond to the scenario with a kind of a thing that could happen in that future world. And I've got a load of stuff on the table, so you could try and make an object that might exist in that future world. And then you present it back to the group, and then we have a discussion. So it should take 2 or 3 hours. Certainly by 8 o'clock, probably about by 7:30. If there's any questions as I go along through this presentation, then just stop me and ask me. I'll be kind of floating around when we're doing the group work, and I'm going to be recording the presentation and the discussion just with audio, and if anyone doesn't want to be recorded, that's okay, just make that known to me. And the gallery have got this camera and they're recording primarily me at this point, but they might record you guys later. But again, if that's a problem, no worries, just let us know and we'll make sure you're not filmed. Okay, so let me turn this light. Cool. So sorry if you're right in front of the projector. I've kind of called this workshop together to talk about artificial intelligence experience, what I'm terming artificial intelligence experience. And although maybe it's not the most intuitive way of understanding it, I want us to start thinking about what it is that an artificial intelligence might experience. In the same way that we think about, I don't know, dogs being able to hear certain frequencies we can't hear, or certain types of beetle can see ultraviolet light, or these other creatures have different types of senses, different types of phenomenologies, different types of ways of being in the world. And as we start to make machines that and act, then I'm curious to speculate about what kind of experiences they might have. And there's quite a lot of assumptions in there, I do know that, but hopefully I can carry you with me and we can talk about those assumptions as well. So, artificial intelligence. You might recognize some of these. So this one you probably recognize. You see her around the place now. This is Sophia, who is a robot. I forget the name of the company, Haslam or something. They made this robot, and it's become this kind of troubling creature that like appears from time to time and advertises communications companies and goes on dates with Cristiano Ronaldo and like appears at conferences. And I don't know if anyone was at Web Summit or saw it, but she appeared with her creator and he kept just kind of like pouring at her and touching her. It's very strange. So there's this weird intersection between gender and robotics there. We've got some other ones on this side. At the top, what's his name? C2 is his name. It's a Japanese robot which is designed to kind of mirror early human learning. So it's this kind of toddler robot. Below it, that's a robot from Boston Dynamics, which is kind of intense robot. Yep, come in. And that's typically that company makes kind of military hardware. We're involved with that. And then right at the bottom, it's a robot who's picking up. That's okay, don't worry about it. I don't know if you can quite see, but it's picking up boxes, sorting boxes, and there's a human just kind of messing with it and kind of push it over and get the box out of its way. So these are some of the things we might think of when we think about artificial intelligence. I mean, crucially, all of these examples have bodies as well, so there's something a little bit more familiar about them. But a lot of the examples of artificial intelligence don't have bodies. They're just algorithms or programs that make decisions, and those decisions impact us. So, how do they make decisions? This is the part called intelligence. So, even if you can't see what's in the bottom corner, the bottom text is data sets, and then we have training, reinforcement, and decision making. So typically, an artificial intelligence program or a machine learning program, to be more precise, would be fed a large amount of data with certain categories. It would be trained on that data, by which I mean it would kind of look over it many times. It would be presented with new information and then try and sort that new information according to what was in the training data. And then it tests itself, it tries again, it tests itself, it tries again, and it can do this thousands and thousands of times until you have a program which is understood to be able to sort new information accurately according to the existing data set. Does that make sense? I can't even see if you're nodding or shaking your head. But that's probably the trickiest bit to understand. Some of the applications of that might be, think of a self-driving car. It's getting all of this information and it's deciding that's an object, that's not an object. That's a pedestrian, that's a car. And I'm going to make decisions based on these choices, which have, I'm going to make decisions based on the way I've sorted this incoming information. So that's the kind of backbone of what's going on. In the bottom corner there, I've got, which I can talk about in more detail, but that one's slightly different. It's a Google algorithm which plays the game of Go, but whereas previously they'd given these programs a load of training data to work on, a load of previous Go games, with this one they just told it the rules and it played against itself until it got really good. And that happened very quickly. So that's a slightly different model, but a kind of quite a new one as well. Just to kind of give a more visual illustration of that, this is a screenshot from a program called Weka, which you feed a lot of information and it sorts the information. So it gets a lot of information coming in, plots a graph with two parameters, works out where each example of data fits on that graph, and then draws boundaries between them. This is, in this one, it's classifying different types of flower based on the length of its petal and things like that. So, to define machine learning, got three possible definitions. The first from computer scientists or statisticians. You've got the systematic study of algorithms and systems that improve their knowledge, which is pretty much what I just described. Ian Witten, who designed that program I just showed the image of, says machine learning is taking the data, warts and all, the good stuff and the bad stuff, and inferring whatever structure underlies it. And that's interesting because it assumes there's already a structure out there in the world that you're just teaching the program to identify. At the bottom, it says, I'll read it, a science by which human decision-making can be abstracted. And this guy's coming more from social sciences, Ramon Amaro. And for him, the important thing is the data that's coming in already has a whole kind of history of human decision-making going on there, which is then abstracted by the machine. So, for example, if you've got an algorithm that's deciding whether to grant prisoners parole from prison, and this is a thing that is happening in America, the algorithm is fed a large data set with information about who reoffended after they were let out of prison. Now, it could well be, typically it is, in the data set that most people who reoffend in America, or in this particular data set, are black. And that's not because they are more predisposed to reoffending, it's because of the way society is set up. So, when this person says a science by which human decision making can be abstracted, all of those human biases, all of those human difficulties in the data are still there in the machine, but they're just abstracted and made more scientific and made somehow more neutral from the way it works. That's kind of a tangent to what we're doing today, but I think it's important to mention it. Okay, some examples of machine learning in action. You guys have probably seen something like this on the left before, right? When you're on the internet and you need to prove that you're a human and not a robot by identifying street signs or identifying cars or something like that. When you do that, as I'm sure many of you know, you're helping to train a computer vision algorithm that is used in self-driving cars. So it's quite profitable for Google to help you do that, but you're also feeding into this process at the kind of training and reinforcement stage. And then eventually you might get something like this. This is a visualization of LiDAR camera, which is the kind of radar camera they put on the top of autonomous vehicles. And I mean, I'm kind of abstracting from the visual here, but if you imagine that's the range of the LiDAR, it's seen something there, it understands it's a petrol station, it's seen something there, it understands it's a person, it understands that's a shop, but it also understands the edges of those objects. And so all of that is as a result of all of the training that's happened at this stage. Right, some more creative uses. And don't worry about reading this so much, but this is the output of an algorithm which was fed all of the Harry Potter books and then asked to write something that was like the Harry Potter books. And it's a recurrent neural network that's working character by character. And I guess that's the important thing. It's working character by character. So it's worked out that after THE, you have a space. Or after the start of a quotation mark, you need to close the quotation mark at some point. And it's actually done quite well for doing it character by character. It doesn't really make sense in terms of like the writing, but what we're looking at is something that looks like writing, even if it's just a structure. So I want to talk about the kind of the experience that's happening in this process. And I've just thrown a few words up here which I find useful as ways to get inside thinking about that, because it's quite an abstract thing. What might these programs dream of if we imagine them kind of going back over what's happened during the day or what they've been learning during the day? how might they sense the world? So what might it be like to have this kind of sense experience rather than the kind of sense experience we have? How might they experience temporality differently? So if they've been reading and rereading Harry Potter for, I don't know, the human equivalent of 100 years, they have a completely different type of temporality than what we have. What about hallucinations or something like that? A lot of the pictures we see that are produced by AIs are quite hallucinatory, and I'll show you some in a second. But the other day, someone described to me a hallucination in AI as being perhaps something that wasn't in the original data set. You know, is that something that's outside of their existing experience? So these are some of the words that I think can help us get inside thinking about the experience of these things. You might have seen something like this before. This is where it's an image kind of produced by a certain algorithm. I've got the information here. It's a deep dream algorithm, which was come up with by Alexander Modvintzer, an engineer working at DeepMind Google. And this was an algorithm to find and enhance patterns in an existing image. And one of the patterns that was privileged for this image was a face. So there are all these kind of half faces kind of floating in the background. Yeah, they actually designed this algorithm to understand what's happening when a neural network is trying to make sense of all the data that's coming in. So I took this image and I fed it back into another algorithm that's available online called CaptionBot. And this is one where you feed it images and it tries to describe what's in the image. Yeah, and it came up with, I think it's a group of stuffed animals, and he seems straight line mouth emoji. Slightly different process, and it says, I think it's a store filled with lots of different fruits, and she seems happy. So there's obviously kind of gaps in the ability of the AIs to do everything accurately, but things like this kind of get working a little bit more. I do just want to speak a little bit on materiality, because right at the start I showed a few robots that have like bodies, but this is the kind of body or brain that a lot of these processes are happening on. This is some footage of a Google data center, and the scale of this thing is really, really crazy. All of this computation's happening there. So it's a completely different kind of materiality than what we might have in our bodies. So that's also something to be aware of when we start to talk about what type of experience they might or might not have. Okay. That's the intro presentation. Shall I turn the light on? Okay. Are there any quick questions off of the back of that? If not, it's okay. They'll come up during the time. Was anything unclear? Was everyone with me?
One question. So you're saying that those robots that we saw in those pictures, a lot of the working out that they do happens in large centres like that, doesn't happen in their sort of human-sized heads?
It probably depends from robot to robot. I imagine that most of the processing happens inside the body, but maybe it's been pre-trained on systems that would be in those big things. But the examples that I showed, the Deep Dream and the CaptionBot, and the stuff I'm going to make you listen to in a second, that was all done on data centers like that. Okay, cool. I'm going to take your silence as a good sign, and I'm going to subject you to the next thing. Okay, so what I'm going to do now is a little bit different. I'm going to ask you all to close your eyes in a moment. I'm going to play some sound. A few days I've fed a piece of audio into some of these learning algorithms, and it's tried to recreate it in a similar way to the Harry Potter thing I just showed you. Now, it doesn't, just to give you an advance warning, it doesn't really sound like the original stuff. and the process is it's been working audio sample by audio sample to try and recreate it. And there's 44,000 audio samples in every second. So you'll see as it comes off. But I'm going to ask you to shut your eyes and just listen along, and I'll kind of talk you through. And I want you to kind of put yourself in the experience, in the mind state of one of these algorithms. So bear with me while I do it. Okay. Cool. So everyone, shut down those eyes. And
oh, the snow, it melts the
imagine you've been asked to listen to this piece of audio. You're an AI. You're somewhere in a data center. Your hard drives, your GPUs are rotating rapidly.
And when a young man tells me that me face he'll soon forget, before we part I'd better crowd, be fain to follow it yet. Oh, the snow, it melts the soonest when the winds begin to sing.
And this is after 950 attempts on the same data. 1,100 attempts on the same data. 3,200 attempts on the same data. Five 5,600 attempts on the same data. And now 5,700, and now we start to get something that's almost like a voice. 5,000. Finally, this one I just printed, which is about 5,800 attempts. Cool. All right, and that's it. Come back to your own bodies. Open up your eyes.
So when you say attempts, what was the instruction for this? To reproduce this? Or
Yeah, pretty much. I gave it. That was a song by Anne Briggs, who's a folk singer from the UK. I gave it one of her records, 2 records from another folk singer, another record from another folk singer. So about 3 hours of audio, and said, you know, learn it and then generate a WAV from it. And yeah, it's still going.
And then second attempt was what was generated, you upload it again? That what was generated, or you uploaded again the same audio?
It's the same audio.
It's same audio, so all those attempts are on the same audio file.
Correct, yeah. So those numbers I was saying is the number of passes it's had. Each pass takes about 30 seconds. So yeah, we're up to about 5,800. It's been going for, I don't know, about 3 days. I'll probably keep it running for 10,000 and then kill it. But it is something starting to emerge from it. But I wanted to play it because it kind of, we hear the voice and then we have a certain set of references to understand the voice. If you're hearing the voice audio sample by audio sample and then trying to recreate it, then a very different thing happens. And it's pretty amazing actually that it even got to something that has a kind of intonation of almost a voice after 5,000 times. But yeah, that's again, that one's out of Google's DeepMind lab and it's called WaveNet. That's the algorithm for that, if you're interested. Okay.
How long do you think it would take?
To do what?
To recognise it. Like
to reproduce something that sounds like it. I heard an example that had been done based on 4 hours of Bach, 4 hours of like classical music, just the piano. And I think there was something that almost sounded like a piano, about 10 or 15,000 cycles. So, yeah, a while yet.
Would you be tempted to just leave it forever?
I would be. I'd love to, but it costs money to run it.
It's always a caption.
Yeah. Maybe one day I'll buy my own like GPU or whatever. But yeah, it would be amazing to leave it running for however long.
And if you chunk it differently, I mean, do you have to randomize it by audio sample, or can you tell it to do it like second by second?
You could tell it. Yeah, you could tell it to do that. You could tell it to do that differently. Yeah, you could tell it to do that differently. I'm using the kind of default settings that are in the library that I've got, but you could definitely go into the files and change it. And if I was doing it over a long period of time, I'd kind of tweak some of those settings and better understand how they were all working. But if it's going to take a week to produce something and then tweak a setting another week, it's like it's too expensive. That's the problem, really. Okay. Cool. All right.
And one more question.
Yeah.
Is this the same algorithm which is used for speech recognition or audio, like sound recognition, like on YouTube, for example, when you have copyright stuff, when they are kicking out your video because you use someone, they recognize that you used the sound of someone else, right? Is it the same, or it's completely different what we are talking about?
It's not completely different. I think it's in the same field, but the main practical application for this is text to speech. So to have a load of text and then say, I want to hear this in this type of voice. They can have, I don't know, 4 hours of recordings of a particular voice and then make it speak like that voice. You might have heard of that in the news because there's some consternation on how this could be used to make it sound like people have said things that they haven't really said, which, yeah, you could totally do. Like in the same way, I don't know if you saw in the news the things about the deep fakes or the kind of the face replacement stuff. The stuff that was getting the headlines was how people were taking celebrities' faces and putting it on porn stars. But I mean, it's a technique that's also used in films as well. I don't know, a film with The Rock in it, and he's jumping out of an aeroplane or something. They had a camera looking at the person doing the skydiving and then just put The Rock's face on it afterwards. So there's plenty of applications for that kind of thing.
I also read also in the paper that they had done something similar with Rembrandt's paintings.
Yeah.
Fed a bunch of them.
Yeah, there's.
In the museum, is that something similar?
Yeah, there's a few things like this. It's the same algorithm as that image generation one that I showed. If I just bring up the web page. Okay, so this is the Google web page. So yeah, you can feed it in a style and an image, and then it will combine the two. So I think this is what you're talking about. Like, there's lots of pictures, I think there's some examples here, of style. Of, I don't know, you feed in a picture of like Edvard Munch or Van Gogh or something, and then it makes your picture look like it's that kind of image. So yeah, it's similar. It's similar school to the stuff we were listening to. You ask it to generate. Actually, it's not so similar. This stuff you're working with an existing image. The WaveNet thing that I played is generating from the digital information, and a similar algorithm is used to generate images pixel by pixel and pixel value by pixel value. So here's one pixel, we'll do the RGB on it. Here's one pixel, we'll do the RGB on it. And so to get an image generated from a library of existing images. But this stuff's kind of quite recent. But there's plenty of, most of the papers are available free online if you really want to dig into it. Cool. Any more? Yeah.
Sorry, I missed your artist talk, but what motivated you to...
Oh yeah, I should say something about that really. Well, my background's in sound, and I kind of worked out after a time that I was interested in the way sound recording equipment kind of captured and represented space. I was always doing loads of field recordings, loads of binaural stuff, like 3D sound, all of this kind of thing. And I was interested in what was at play with the realism of the sound and its reproduction. So this I kind of see in the same field. There's something in the world, and then you're feeding it through a process and then representing it. But there's also these questions of kind of power and control, and like questions of what this thing is that's processing the world and then representing it to us, and perhaps what are some of the power relations involved with it. Yeah, that's the short answer. Okay, time's ticking, so I do want to move us on to what I want you all to do today. Now, I mentioned that we're going to work with this kind of future scenario, and there is a kind of technique which is this the right one? There's a technique which is being used quite a lot in London, the RCA, where you give people a kind of future scenario, and then you say, think of something that could exist in that world. So it's called speculative design, and typically you would say, in the future, XXX, I don't know, like there's data inside everybody's bodies, or something like that, some kind of science fiction-like scenario. Now, in order to think through that possible future, create an object or a situation that could exist in that future. So that's more or less what I'm going to ask you to do. And I'm going to give you a scenario in the future that is to do with AI's dreaming. I should show you this other slideshow, which is some examples of projects that people have done before. This is when I was doing work with GPS. So this group's concept was that there are certain people called silverheads who want to hide themselves from an all-powerful GPS network. So they enclose their phones in concrete, and they walk around all the time with these things on their heads. And this does present a few social problems, because most people are completely on board with the GPS thing, the all-powerful GPS thing. And they're like, well, what have these people got to hide? So this group developed this concept and then kind of used these materials to present it to the group. This group did more of a kind of storyboard. This was a workshop working with designers, so this was kind of their bread and butter. And this was a scenario in which the all-powerful GPS network confuses people on the ground and contains them in certain areas so that the natural world can kind of rebuild itself in the absence of humans. So it was the idea of a GPS system as a guardian. This group came up with a board game to represent the idea that different all-powerful GPS systems were competing against each other for resources and for people's attention, and they were competing to purchase famous tech brands. And this one was a bit more abstract, but this group came up with the idea that people would build kind of certain types of architecture that would deflect GPS signals, and that's what's depicted from this kind of this shape made out of paper. And we're going to be working with like paper and crayons and scissors and plastic bottles and stuff like that. So there's no kind of technical prerequisite. If you have brought your laptops and really want to like make a kind of nice image with your phone cameras or whatever, then that's great. I'm going to put this. I've got this on printed as well. I'm going to give it all to you in a second. But this is the scenario that I'm going to ask you to look at. And I'll put you into groups in a second. But just together, in 2040, AIs have overtaken a huge variety of tasks, driving cars and trucks, deciding mortgage applications. Oops. You're right. Oh, that's all right, yeah. Maybe just lower it down. Yeah, so these tables aren't the most stable. That's good to know for the next stage. Offering parole, it has been discovered that such programs are less prone to breakdown and more able to work effectively when they are flipped into a sleep mode, where they reprocess the data they have just run through different neural pathways. So the analog here is something like human dreams. It is recommended that each program spends half its time in this sleep mode, but while some see this as just another form of machine learning training, the dreaming also causes outcomes such as the production of sound and images in the software's logs. So this is the scenario. It's 2040 and most technologies are working this way. So what I would like you to do in your groups is come up with a scenario which could exist in this world, and that could be with a focus on the machines, or it could be with a focus on the humans or the way they work together, and illustrate that scenario that you come up with by making some kind of object or some kind of presentation. It could be like a physical interaction, it can be something made out of paper, but you're going to have to explain it to the group in about an hour and 20 minutes time. I'm going to turn the light back on, and I'm going to hand these out in a second. Alright, so that's what I want you guys to do. Are there any questions at this stage? I'm going to be floating around to answer questions. Okay. Cool. Let me just count how many people we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay. So let's do groups of 4? 5 groups of 4? Does that sound right? Okay. Cool. I mean, do you guys, do you want to form yourself into groups of 4? Or would you like me to go 1, 2, 3, 4, 1, 2, 3, 4? You're all grown people. You put yourself into groups of 4. Cool. You're a 4. Look like you're a